Hey, good morning, everybody. I'm having some problem with the audio. I hope it's working for this, but we just gotta wait and see till we're done with the video. This is going to be a real short video. I'm happy to say probably the shortest one I've ever made. Indirect measurement is the last thing we're going to talk about when we're talking about similar figures. It is a real practical application of similar figures. It's a way to measure stuff without actually having to get a tape measure long enough to measure it. Okay, so if you had to find, for example, in this one, we got to find out how tall a tree is. So read the problem. There's a tree you got to cut down. The only building or anything else around is your house. It is 87 feet away from the base of the tree. You need to decide if you can cut the tree down and not care how it falls, or do you need to make plans so that it makes sure you fall away from your house because you don't know how tall the tree is. Because if the tree is 100 feet tall and it falls onto your house, that's 13 feet of your house that you're not going to get back, or you got to fix or whatever. Anyways, so if you read the problem, it says that you are 6 feet tall and your shadow at this particular time of day is 5 feet tall. You measure the shadow of the tree and find that it is 75 feet long. How tall is the tree? And can you cut it down without caring how it falls? So if you are 6 feet tall and your shadow is 5 feet tall, long, whatever, and you got this tree, it's tree, okay, fine, I'll do this one. How about it's a tree, horrible tree. I am not an artist. That's a tree. And we don't know how tall that is, but we know the shadow of the tree is 87 feet. And, oh no, excuse me, the shadow of the tree is 75 feet, my mistake. Okay, so here's the thing. Because the sun is causing this, the shadow, and it's taken at the same time of day, this angle right here and this angle right here are the same angle. And this is a 90-degree angle, assuming that you stand up tall when you get your height measured. The tree is hopefully growing straight up as well. So in any case, we just need to know how tall this is. Thanks to angle, we have similar triangles, and so we can just set these up. 6 corresponds with x, and 5 corresponds with 75. 6 times 75 would be, excuse me, somebody's going to come on the announcements here in a minute. 6 times 75 is going to be 400. Well, let me write it out first. My apologies. 6 times 75 and 5 times x. 6 times 75 is going to be 450. And 5 times x is just 5x. And then you divide both sides by 5. And that is 90 feet. Therefore, if the tree is 90 feet tall, can you cut it down without caring how it falls? Nope, because at 87 feet, it's going to hit your house. So you're going to lose about 3 feet of house. So you have to, arrange it, cut it a certain angle, certain way so that it falls away from your house, or just not directly at it. Next one, we've got same type of problem, except we're looking at the height of a flagpole. You need to know how tall it is so that you know how big a flag to purchase. There is actually a law, I guess, or there's like a standard you're supposed to have. If you want to fly a flag that's so big, you have to have so tall a flagpole. And I remember there used to be a flag flying in Dallas, Fort Worth area that was like the size of a football field. It was like one of those they take on the football field for like the national anthem. And they had to have this gigantic flagpole for it.
Happy Monday, teachers.
But in any case, you just had to have a certain, you have to have a certain height of a flag pole to fly whatever size flag you're flying. Because you don't want it to be a big flagpole with a little bitty flag, because that would look weird, and you don't want a little bitty flagpole and a ginormous flag. It might, hit the ground or whatever. So anyways, it's cloudy day, so you cannot use the trick with shadow that we talked about. So you take a mirror and you place it 20 feet from the flagpole. So here's our flagpole. I can draw that. a little ball on the top. You put a mirror 20 feet. This is 20 feet, and here's the mirror. Okay, then you measure the distance. You step backwards until you can see the top of the flag in the mirror. Yeah, top of the flagpole in the mirror. So I said building. It should be flagpole. Sorry. So you step back, and it says 2 feet 6 inches. I'm not going to put 2.6. It would be 2.5. That's 2.5 feet. And you are still, it says 6 feet tall. So this is 6 feet. So the way this works, guys, is if you're looking down at this and you can see the reflection up here, this angle and this angle have to be the same because of the angle that you're looking at it, and also these would be right angles there. So by angle, these are the same as well, or similar, excuse me. So I can set this up where X would correspond with the 6, because that's how tall the flagpole and I are, or you are, and then the 20 would go with 2.5. So we cross multiply, we get 20 times 6, and that's going to equal 2.5 times X, and 20 times 6 is 120, and that would be 2.5X. And I am just not sure, what is 120 divided by 2.5? 120 divided by 2.5 is 48 feet. All right. So that is indirect measurement. It really does work. Anyways, try it at home sometime. Find out how tall a tree is. It's something you can certainly do. All right. Y'all have a good one.